নমস্কার, শুভ সন্ধ্যা সকলকে। Good evening or good morning, everyone. I am Samrit Pramanik, uh, the lead organizer of Kolkata R UseR Group, and a warm welcome to the Kolkata R UseR Group second virtual meetup session. Let me, yeah, and the screen is visible, right?
Yes, it is visible, Shamrit.
Yeah, okay. So, yeah, thank you everyone for joining with us today. And I would like to take a moment to highlight our Kolkata R User Group's activities. So last month we had an exciting session on everything with Quarto, where I have discussed on how to build websites with interactive web contents, publish reports using R, Python, and Julia, write books and thesis manuscripts for professional and academic uses. The recording is now available on our YouTube channel. If you missed it, you can do check it out, please. And stay tuned because we have many more sessions lined up in the upcoming months with some awesome and reputed speakers around the globe. Our group is proud to be a diverse and inclusive community, welcoming individuals from all backgrounds and industries, whether you are from a life science, healthcare, physics, astrophysics, or any discipline, economics, academia, or even industry, or any other field, you are welcome to join us. Our goal is to foster a vibrant community of art enthusiasts in Kolkata. And we believe that the diversity of the perspectives and experiences is essential to achieving this goal. So, whether you are a student, researcher, professional, or simply curious about statistics, data science, and R, we invite you to join our sessions, ask questions, learn from each other, and let's build a community that thrives on collaboration and mutual growth. And one more thing, I just want to let you know that I recently got the opportunity to interview with the R consortium team. There I have shared my thoughts, my approaches, and the history of Kolkata's legacy on statistics and data science and R. So their blog post was published from the R Consortium's official web page and also from their LinkedIn page. So please do check it out. I will also share the link of that blog post in the chat section in some time. So please follow us and do support us. And today we have we are honored to have with us a distinguished speaker, Dr. Abhimanyu Gupta, who will entertain us, enlighten us on the topic a new approach for teaching data analytics with R. So Abhimanyu Gupta is an instructor of data science at the Richard School of Business at St. Louis University. He has an impressive background holding a Master of Statistics, that is MStat degree from ISI, the Indian Statistical Institute, and currently pursuing his PhD at Ghent University, Belgium, since 2017. Before academia, Obhi worked as a project manager in the information technology industry for 17 years. He has received numerous awards for his teaching excellence, including the Immersion Excellence in Teaching Award in 2021, Graduate Faculty of the Year Awards in 2020, 2021, and 2024, and the Beta Gamma Sigma Outstanding Teacher Award in 2023. Ovi is also a thought leader on LinkedIn, sharing insights on data science with his 11.5 thousand followers. So in this session, Abhimanyu will share his innovative approach to teaching data analytics to business students, focusing on principal problem solving with R. He will discuss how to shift the emphasis from technical implementation to finding hidden patterns in data and enabling business students to drive informed decision making. So thank you once again for joining with us today. Over to you, Abhimanyu.
Thank you so much, Shamrit. It was a nice introduction. I'm honored to be here today as well. And can you hear me okay?
Yes, yes, yeah,
Okay,
go ahead.
okay. Um, So one quick correction. I did finish my PhD last September. So
Oh,
I
okay.
mean,
Hmm.
so I'm still not comfortable with this doctor thing in front of my name. I'm working on that right now.
Hmm.
But Uh, thank you so much for the invitation, and I would love to talk about what I do at the Sheffield School of Business of St. Louis University as a data science instructor, and how I work with the students and how I contribute to popularizing R as data science or data analytics language here. So. Um, Before I start, I just wanted to give a disclaimer that it is not going to be a typical discussion where I will teach about R. Rather, I would try to show you a perspective of how R can be popularized among the non-technical people and how I am doing it with my small initiative in the business school where I am teaching this. So with that note, I want to start. Let me share my screen very quickly. There are a
Yeah.
few, there is one slide that I created. There are a few pointers. Um, um, Suddenly I cannot share my screen. One second.
Mm,
Oh, this one.
yes, yes. Your screen is shared now.
Share. Okay. No, I did not want to share this screen. I wanted to share the other screen. Give me one second, please.
Okay, okay.
Okay. Can you see my screen? There is one blank page with just one header, which is
Yes,
the
yes.
title.
Yes,
Okay,
yes. Your screen is
awesome.
up. Yeah.
So thank you so much, and everyone, please feel free to share your comments or ask questions during my presentation. So I love to be interrupted because I think conversation and debates are very useful tools in the learning process. So feel free to interrupt me. Feel free to share your thoughts, ask questions. I'll be very happy to have a conversation with you. So I will start with my journey to academia. That means how I came to academia. As Shamrit was mentioning, I was working in the information technology industry for a very long time. I was working there for about 17 years until I hit my midlife crisis and I wanted to do something else, and I started my own company that did not go very well, but that kind of led me to an academic position as an adjunct or a part-time instructor in one of the schools, and I started teaching there in 2017. Around that time, I kind of decided that I'd stay in academia for some time. So I decided to pursue my PhD. I applied for it, I got it, and I started my PhD in 2017, which I finished last September. And uh, that's how I came to academia. So I taught my very first course in life in 2017, where I had to teach a business analytics course. And I was teaching in a business school. I still teach in the same business school, but these are business students. These are not very technical students. So the first thing that I realized, and I come from kind of a technical background. I'm not very technical, but I am kind of from a technical background. I code a lot. It's not that I can call myself a good developer or something, but yeah, I'm interested in coding. I code a lot and everything, and I I carried that mindset in the classroom when I started teaching the courses here. And I did not realize that these are business students. And whenever someone comes to the business school and they want to study business, they do not have to be technical. They don't have to have knowledge in any programming language. They do not have to have knowledge in mathematics or statistics, but they need to understand how it works, right? so that it can be used in their organization. They probably will not be hardcore data scientists or data analysts, but they probably will be managing the teams of data scientists and data analysts. So I started realizing that, and I was trying to tune my teaching for them in such a way that they know what is possible, they know what can be done, and then they can delegate things to the more technical people, more technical data scientists and data analysts, so that they can do things for them. So it took a few months, maybe a little more than a year, for me to figure out that I need to tune my teaching of statistics and analytics for these students. Remember, when I grew up, I did my bachelor's in BSc in Presidency College through Calcutta University, and I did my master's in Indian Statistical Institute. And every time, every single statistics class that I attended, it started with the statement that x1, x2, xn are IID normal. And that does not make any sense to any of the students that I teach, because they don't know it. They don't know mathematical notations, but they want to know how data and analytics and statistics can be applied to make better business decisions. So that was the mindset switch that I need to make. And I started learning it. And before me, in this business school, actually, there were not many people who knew all those things. So their analytics courses were restricted till data visualizations, Tableau, and Power BI, and all those things. But I really wanted to show them what is possible in the business world, um, with the advanced concepts and techniques and tools. I mean, things like supervised learning, prediction, unsupervised learning, clustering. There are so many things that you can do with your data that will help you make better business decisions. And I wanted to show them all those things, but unfortunately, I could not do all those things without an appropriate tool. So I had two options, Python and R. And I tried both of them as an experiment in a couple of semesters. And I figured out that the students are, particularly the non-technical students who are not very familiar with technology and coding and who have never done any coding before in their life, they are little more comfortable with R than Python. I figured that out from my own experience. And um, probably one of the biggest reasons why they were comfortable with R versus Python was the fact that for the non-technical students, it was very easy to install packages through R versus through Python. That's what they told me, that we need to, installing a package is much more technical, at least to these kind of students who are not very technical, who have not done all these things before. They said that I can just type the code, install our packages, and I can install a package in R, whereas in Python, I'll have to go back and do all of the things that I do not understand. Right? So that is one of the primary differentiators of me for me choosing R over Python in the business school. So I put a lot of effort. I integrated R with the courses. I introduced the topics that were never taught before in these courses. Again, like supervised learning, linear regression, logistic regression, random forest, decision tree, XGBoost, and at the same time, principal component analysis, cluster analysis, all those things. But and also I wanted to started teaching them with R. But then there was another challenge. I spent a lot of time figuring out where is the problem with the code for each of the individual students. So I was going to the individual students, I was going to look at their individual laptops, and after 10 minutes of work, I was able to find out that there was a comma or a dot or a semicolon that is missing there. And they did not understand that. They have never done coding before. And again, if you think about it, for a business student, it's not even important to be an expert in art. They just need to understand what is possible with data science, with statistics, and everything. And that made me think a lot. I mean, how I can teach these non-technical students advanced data analytics or data science concepts with R. And I thought a lot about it. And around 2018, 2019 timeframe, I came up with a solution. I call it Stats Buddy. It's a website. It's a website of code generators. So what I do is I have created this website for my teaching. I had to learn JavaScript to do that, but I was able to do this, and I started very small, and I'm going to show that to you right now, that how I use that. And the whole idea is this, that the business students do not have to focus on the how to, they need to focus on the what and the why. Right? Why I'm doing cluster analysis, what I'm going to get out of it. Or in a particular problem, there is this business problem, how do I approach it? And I started, teaching them, think about how a business problem can be solved. So for example, I have worked with many technical students too, and if you tell them to feed a random forest model on a particular data set, they'll be able to do that like this. But if I give them a real problem, a real business problem, in many cases they are not very good at finding out which technique to approach, which technique to apply here, and how to approach it. And that is what I wanted to teach to my business students. And I always gave this analogy to my students, that imagine that I am teaching you carpentry, right? Imagine I'm teaching you carpentry and I am bringing a toolbox with me in the classroom, and I'm taking one tool at a time from the toolbox. First, I take out a screwdriver and I talk about screwdriver and I show you how to work with screwdriver. Then I take out a hammer and I show you this hammer, and I teach you how to use this hammer, right? And similarly for other tools as well. But at the end of it, a typical business problem might look like this, that I will show you a picture of a chair or a table, and I will ask you to build it. Now, knowing the individual tools is very important and how to use them is very important, but what is even more important is to find out when to use which tool. Should I approach it with supervised learning? Should I approach it with unsupervised learning? Is it a very simple problem that way I can solve with simple data visualization, or something else? I mean, what exactly we can do? I mean, what is the best thing to do here? I think that is, I have found from my experience that that is the biggest challenge, that I know how to do this, I know how to do that, but I do not know what to do here. So I was trying to focus my teaching to what versus the how to. So let me show you how StatsBuddy looks like. And this is an open website. Anyone can access it. The URL is statsbuddy.net. So anyone can go and access it, and it has a number of pages that will help you with the generation of the R code. So first thing I'm going to show you is how we can use this with simple statistics. And I started using that in my class, and people started getting the benefits out of it. So what I'm doing is I went to the statistics menu of this, and then these are some of the topics that I teach, right? So let's say there's a problem that there's a normal distribution with mean 25 and standard deviation 10. What is the probability that my variable, the value of my variable will be more than 35, right? Um, Now, this is a very simple scenario, and we don't have to use R necessarily for this. We can now do this with Excel or other simple things. But this was the starting point for me to build this for other technical situations that not many other tools can take care of. So what I will do, for example, is I would go to statistics, and among these pages, I will work with the normal distribution with R, and it's a very simple page. And let's say the mean is 25 and the standard deviation is 10. And what is the probability that X is more than or equal to 35? So I'm going to check this. I'm going to change it to more than equal to, and I'm going to type 35 here. And if I click create, it will give me the R code. So I can always copy the R code. I can come to R and I can find the answer. Now, again, this is just a starting point, and you do not necessarily have to take this approach for solving this particular problem. But in the university, we wanted to develop a unified, a standard approach for teaching everything, so that the same approach can be used to learn how to do other things as well. Now, then when I started thinking about it later on for analytics courses and more advanced courses, I created this analytics tab. And what I'm going to do is I'm going to show you a very complicated scenario where, let's say, you have the iris file. I'm pretty sure you know you are familiar with the iris file, right? So I'm going to let me change the. I'm so sorry. Let me change the font a little bit. Maybe. I'm sorry. 1 second. This is much better. So what I'm going to do now is I'll take the iris dataset and I am going to ignore the species column. I'm going to only focus on the first four, the sepal length, sepal width, petal length, and petal width. And I am going to find out myself, assuming that the species column is not there, how many species might be there, only based on the values of the four variables like sepal length, sepal width, petal length, and petal width. Again, I'm imagining that the species column is not there, and I am going to try to guess how many species might be there, right? Basically, I am trying to understand how valuable is the species column. Is this really um, is it really adding any value to the data set, or there is something that we can figure out ourselves by using some advanced techniques. So let's say that is the business problem. The question is how we can do it. Of course, the answer is cluster analysis. But we cannot just directly go ahead and do the cluster analysis. There are a couple of steps that we need to do. So that's why, and that's how these individual techniques and the sequence of them and finding out what to apply when, all those things, all those concepts come into picture, right? So I have downloaded the file here, and I am going to use StatsBuddy. And using StatsBuddy, I am going to run 4 steps, one after the other, in front of you. So this is the data file, just so you know. This is the CSV file, and I'm going to run the 4 steps to understand what is going on here. The first step that I'm going to do is, let me explain that first, and then I'll go ahead and do that. The first step I'm going to do is I'm going to not 4 steps. I believe I'll do 3 steps. The first step I'm going to do is I'm going to do a principal component analysis and find out whether we really need 4 columns or we can work with lesser number of principal components. Then we're going to take those principal components and we are going to first create a dendrogram to find out how many clusters might be there, and then we'll decide on the number of clusters. And then we'll take that number of clusters and come back and apply a k-means clustering with those number of clusters to assign the clusters to the individual rows. So that is how we are going to do it. And I'm going to quickly show you how I'm going to do it. So first in the analytics column, I can come to dimensionality reduction, and there is a page that I created. I'll choose the iris file and I will select the first four. As I mentioned, I'm going to ignore the species column. So I chose the first four and I'm going to do a principal component analysis. And then I'll hit the create button. As I hit the create button, as you see, that the R code is generated. Now, I want to pause here and talk about something else for a second. If you are a non-technical person, if you're a non-technical students, if you know the basic intuition of principal component analysis, you can just copy it and you can come and I'll make sure that it's pointed to the right directory. You can come here and you can paste it. And here you go. The principal component analysis is done, right? And this new file is created called iris_pca. You see the four principal components are created here. But if you are a technical student and if you are motivated to learn R, you can use this as well. How? Let's say you do not want to scale it and you do not want to center it. How does the code look like? If you do not need those things. So you change it, you create, and you see this line changed. And this is the exact syntax. So by playing with this, my idea is that if you're a technical student, you still should be able to learn R with this. If you want to, remove this, how does it change? So you see, for a technical student also, a code generator can be of tremendous help because by doing trial and error, you actually get to see how the R code changes. And that's how you learn how to write the R code. And for the non-technical students, you don't have to worry about it. You just copy and I'm going to, change it to true. So you can just blindly copy and you can come to R, make sure that it's pointed to the right directory with that contains the data and then you run it. And it will not only create, it will also save it as a CSV file. So now this was my input and this is my output for the first. Then after the principal component analysis is done, what I can do is I can go back and look at the proportion of variance and we can decide, let's say that we're going to use only the first three principal components because the fourth one does not contribute much. So let's say that the overall decision is that we are going to use the first three principal components. And now in step 2, we are going to create a dendrogram, a hierarchical clustering diagram to try to understand how many clusters might be there. So again, I can come to Stats Buddy, I can come to Analytics and come down under Unsupervised Learning Cluster Analysis. Now I can choose the _PCA file, which was the output from the previous step, and read the file. I see the PCs, and as I described before, I'm going to only choose the top three principal components. And this time I want to do a hierarchical clustering, so I checked it. And you can play with the methods and all those things. But anyway, let me go ahead and create the code. So the R code got created. And then again, I'm assuming that I'm a non-technical student. I'm copying it. I'm coming to R and I am pasting it. So as you see, it automatically created the hierarchical clustering, the dendrogram. And from there, statistically speaking, we can actually go with maybe either 2 clusters or 3 clusters or 4 clusters. It's difficult to find out which one is more accurate. We can always go back, and if you are familiar with this, then you can always come and do a elbow method here as well. Let me show that to you again. Um, in addition to this, so if you know about this, you can always do the elbow method. As you see, oh, sorry, I think, oh, there's no package. Oh, I think there's a problem with the package. Let me try it once. If it does not work, then we'll move on. So anyway, we can install the packages, and as you see in the generated code, I have commented the install packages code, because you don't have to install them every time. But these statements will serve as a reminder that you need to have these packages installed. And when you're running it for the first time, what we can do is, after the code is generated here, you can just manually delete the hashes for the first time only, and that will first install the packages, and that will uh, load the packages and do the work that it needs to do. It is still not working, but you see my point. I will go with 3 clusters or 4 clusters, let's say. I believe I have the dendrogram saved here. It's opening somewhere else, but probably I will go with 4 different clusters. Shambrit, can you confirm that you can still hear me?
Yes, yes, I can hear
Yes,
you.
yes. Okay. I just wanted to make sure, because it looks like my computer is getting slow now. That's why I wanted to
Hmm.
make sure. So let me go ahead with 4 clusters. Let's say that is the best information that I have at this point, where I do not have the species column. So now I'm going to go to StatsBuddy and use the same page, and I'll come to partitioning clustering with k-means, and I'll choose number of clusters as 4 and create it, and it will do a k-means and copy. Let me see if R is ready. Something is going on. I'm so sorry. Oh yeah. So yeah, let me try the elbow method once again. I believe it was done. I'm so sorry for the size of the font. I mean, I was not able to work with a bigger font. I was not able to show you things. So let me go back and do the elbow method once again, with the hope that it will run this time. If not, we'll just move on. Oh, it worked. So it actually says 5 clusters, or yeah, maybe 5. But anyway, let's go ahead and work with 4, as we discussed before. But I just wanted to show this to you as well, so that you know that sometimes it is possible to do all these things too. Now, let me come back and do the partitioning clustering with 4 and copy and paste. And then it created the irs underscore pca underscore clusters. So I'm opening the file to show you the clusters column. You see the clusters are created. And we can always check how close this is with the species to determine, to understand how useful the species column is. But we are not going there, because the objective and the purpose of this session is not to show you the strength of cluster analysis per se, but to show you how it can be worked with by the non-technical students. So So yeah, I mean, I just wanted to show you that this is how my students first understand the concepts intuitively. By the way, one of the hardest concepts that I have found to teach them is principal component analysis. But they slowly get it. I mean, I spend a lot of time talking about it very intuitively, not mathematically at all, but very intuitively. And so what is the benefit of it, and how it works, and then the cluster analysis and everything. So coming back to the slides. So that's how the Stats Buddy was born, and I demonstrated to you how to work with statistics, very simple things, to very complicated things like cluster analysis, and how this can be done pretty quickly, where the business students will be able to focus on the what's and not the how's. Uh, but the benefit that they get is that they see that it's possible. On top of that, they get an experience to work with R. So they can actually talk about R. In their job interviews and in their day-to-day work, they actually use R, probably without knowing much about it, because there is this new layer of stats buddy. But it for many of my students, it works really well. And many of my students have contacted me much later after they graduated and after they started working as a data analyst. They contacted me and said that they still use StatsBuddy. And once again, this is a free website. Anyone can access it. I made it public for a reason, because whatever I wanted to teach them, I wanted to make sure that they can use them later on. So, so that was the idea for StatsBuddy that I conceptualized and created. But there is one more thing I wanted to show you. It's about the what, and this is what I had been talking about, the what versus the how and everything. If I give you the data set, and if I ask you to fit a specific model, I'm pretty sure many of you will be able to do that pretty easily and pretty fast. But if I give you a specific business problem, then it's a different skill. It's a different mindset. And I try to make my courses much as real life as possible. So very recently, I'm sorry. Very recently, I actually came up with the idea, and I wanted to share with you. I will not take more than about 5 more minutes. But there is another idea that I'm working on right now, and I'm excited to share with you about that. And it's not necessarily about R, but it is a new idea, new concept, new website that I created. Let me show you here. So for the last few months, I had been working on creating online games through which you can actually you can play the game, you can download the data, you can analyze the data, and you can create the strategy from your findings of your data analytics, and you can go back and play it once again with your strategy right now. So let me show you one of these things that I use in my courses as well, and I very recently I made it public. So this is the website that I created, and there are some games here. I'm going to show you one of the games. I want to show you the retail coupon game, and this particular game is free for everyone. So feel free to download it and play it. But let me show you how it looks like. So the background is this: that let's say you are a store manager of a departmental store, and your corporate had created different types of coupons, especially 3 types of coupons for you to distribute to your loyal customers. And they did not give you any strategy because the corporate thinks that distributing them randomly will motivate them to increase the sales. But you think let's say you are data analytics minded, data science minded. You understand data and you understand the power of the inherent insights from the data. So you want to find out a strategy to distribute the right coupons to the right people. So for the loyal customers, for example, you have some very basic information about them, like their age, their gender, whether they're married or not, how many children they have, and their income group and everything. So every time a new customer will come and you will issue a coupon. The moment you issue a coupon, it will show you how much money this customer spent after the visit in your store. And for the second one, after this, it will add up your revenue and it will calculate the average revenue per customer. And every time you do this, the data will be um, the data will be recorded here. Now, if we keep going this way, I'm not going to go very far with this, but after some point of time, you can download the data, and it's a CSV file, and you can use the CSV file to do the analysis, and then you can find out what is going on. And this will be long. I just showed you a couple of the rows, but this will be long, and you should be able to analyze the data about what is increasing the revenue, what is the most important factor, and what should be your strategy. That maybe distribute coupon A to mostly the female, distribute coupon B to the married males, distribute coupon C to the unmarried males, and things like that. What should be your business strategy, and you should be able to find that out pretty. I mean, if you are familiar with data analytics and data science, you should be able to do this pretty quickly. And so your objective is to find out that strategy and then go back to the game once again and play it and see an increase in the score. So that is what I came up with to emphasize more on the what versus the how to. So this is a situation, and I try to work with a lot of companies for getting some dummy projects or internships and things like that. It's hard to get, and most important factor behind that is the data privacy of those organizations. So I wanted to do something about it, and so I created this gaming website where the game generates the data. So there is no data privacy issue and all those things. You can, and it will help you learn data analytics, mostly in terms of what to apply versus how to apply something. So I believe that's all I wanted to show you. I think it's a good time where we open the forum for questions.
Yeah, definitely.
Yeah,
Thank you,
definitely. Thank you,
Abhimanyu, for this
Abhimanyu, for
insightful
this
and
insightful.
thought-provoking talk. We are grateful for your time and expertise in sharing your innovative approach to teaching data analysis and analytics to business students. And the last thing that you have showed is very, very interesting to me as well. So yeah, anyone, if you have any question, you can ask in the Q&A session. That there is Q&A section is there in your MS Teams, or you can unmute yourself and directly ask him. Anyone?
Somrit, I think I have a question.
Yes,
Sure.
yeah, go ahead.
Yeah. Uh, Thank you, sir, for the great talk. And fully, so it's a really innovative techniques how you have developed a teaching architecture to uh, include many of the data scientists, aspiring data scientists. So I have questioned that most of the thing for thinking on R, actually a basic knowledge of statistics is required. So how you tackle that to the students to input that thing first and then to do with R, because to deal with normal distribution and like that, they have some basic, they need some basic knowledge in statistics. So how will you deal with that?
Great question, and I have a lot of thoughts around that, and Shamrit, that can actually be a whole separate session.
Yeah.
because I have so much to talk about. But Orgo, I want to show you a few things very quickly. First of all, um, I emphasize about how what is statistics and how it is different from mathematics.
Yeah.
And usually probably you have heard this too, and I think we all did, that most of the people says that statistics is very hard,
Yeah.
right? And my hypothesis is that it's not because of the subject, it's because of how it's taught.
Yes. Yes.
And
Yeah, yeah,
right, and I put a lot of effort to change that too. So I start with this, that mathematics assumes a universe around us that is deterministic.
yeah.
But there are some problems with that. To give you some examples, um, when we are working with astronomical things like solar eclipse, we should be able to fit a mathematical model very accurately to predict the start and end time of a solar eclipse precisely,
Mm,
only with using mathematical models, right?
yeah.
Um, if you go down chemistry, for example, if you have two elements and you mix them under the right temperature and pressure, it will produce the exact same compound every time. There is no variation to that.
Mm,
So at the very high level and at the very low level, things are very deterministic. But then why the things are in the middle, like our lives, why they are so uncertain? Why our lives and activities and decisions cannot be um, modeled with mathematics, right? Because there's so much of uncertainty that we go through every day. And the answer to that is that it can theoretically still be modeled with mathematics if we have all the right variables in place.
mm,
Correct.
But in our daily life, there are so many variables, maybe billions of variables. Imagine you getting a job. You got a job because incidentally, some other people applied for it who were not as good as you. If you want to model this, you think about how many variables you need to consider,
Hmm.
right?
So,
Maybe there was one particular candidate better than you, but he or she could not show up because there was an accident on his or
yeah.
her way, right? So imagine that if we want to, model all our activities and decisions through mathematics in our day-to-day life, it's going to be a huge model,
Yes. Yes.
and practically it's not possible to deal with that.
Hmm.
So what we do is we restrict ourselves to only some very important variables that are influencers,
mm,
and we call everything else as randomness. So in other words, randomness comes from lack of information,
Yes. 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 That's true.
right? Now, the question is randomness, is there a structure in randomness?
Yes.
Can we study randomness, right? And that's when I say that statistics is nothing but the study of the structure of randomness.
Yes.
That means there can be a system that can, I'm just giving an example, there can be a system that takes a value between 0 and 1.
Yeah.
But its structure, if there are two systems like that, the structures can be really different. One can be uniform, other can be a very extreme beta
Hmm.
distribution,
mm,
for example, right? So statistics is nothing but study of the structure of randomness. And those structures we technically call probability distributions.
Yes. Yes.
And then I use a Galton board. Are you familiar with the Galton board? Then
Yeah.
I use a Galton board and show them that, well, there are so many uncertain processes around us and we cannot
Yes.
control it. For example, take the example of childbirth, the gender of a
Mm.
child, male or female. No one has any control on that, thankfully, right? You know why I'm saying thankfully, right?
Yes.
Um, Thankfully, that we don't have any control on that, and it's very random. That nature
Mm.
is able to balance the males and females in its own way. Well, I don't mean to be philosophical here, but you see, a system has its own way to balance things and maintain a structure, right? So statistics is a study of the structure of randomness. We might not be able to pinpoint what might be happening, but we can say something about it after we study the structure of it. And specifically, at this point, I introduce the Galton board, and then I intuitively establish the fact that normal distribution is not something we invented. It's a natural process.
Okay.
So that's how I try to do that. I'm not sure,
Yeah.
Orko, if I could answer your question.
Yeah. 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 That's a good answer, and I think how you defined the randomness, the thinking of randomness to the students is remarkable. So thank you for the
Thank
great talk.
thank you very much.
Yeah. Yeah.
Yeah. Thank you again. So anyone, any question? Anyone else? No one. Okay. We have 2 minutes left. So anyone, if you want to discuss anything with him or any question in your mind, you can ask.
And you can always contact me at any point of time if you have any questions later. I mean,
Hmm.
Shamrit, I'm not sure if you have my email or not, but I'll send you my email and you can share this with everyone, and anyone can
Yeah.
email me
Hmm. Hmm.
with their
Yes. Yes.
questions.
Sure. I
Or,
would. Huh.
go ahead, sorry.
No, I would request you to just share the link of your stats buddy to in the
Oh,
chat
sure,
section or in the Q&A section,
sure.
so everyone can access from this.
Absolutely. I'm going to share both the links, the stats buddy for the code generation and Gamelytics for the
Haha, yeah,
gamers
yeah.
too.
Yes, yes, yes. Sure, sure.
So let me do that right now. Yeah, I just shared the two links.
Yeah, yeah. Got it. Yeah. Okay. Thank you. Okay. So I think we can wrap up now.
Thank you so much for this opportunity. I really enjoyed talking to
Yeah.
all of you, and please feel free to contact me if you have any questions, comments, or anything for me.
Okay. Yeah. Thank you. And to our audience, thank you for your active participation. and engagement. We hope you found this session very informative and useful. Until next time, thank you once again, and we will be coming back in next month with another meetup session. Okay. Good night, everyone.